Good afternoon, ladies and gentlemen. Uh, this is Vinay Babu, National Manager GIS at EDS Technology. I head the GIS business. First and foremost, we thank each and everyone for taking your time out in joining this webinar. Welcome to our webinar on accelerating sustainability in mining with geoanalytics. I'd like to begin this webinar by giving a short introduction about our company, EDS Technologies. EDS Technologies was incorporated in 1994 to focus on providing technology solutions to enable organization to adapt the right technology for business innovation and growth. For this, we have partnership with technology leaders who are the best in their field. Today, we are one of the largest technology solution provider in India within the segment and application area that we cater to. We have served more than 2,000 customers across multiple segments such as transportation, mobility, aerospace and defense, natural resources, infrastructure, etc. To ensure that we are closer to our customers, to understand their needs, and to service them better, we operate in a total of 9 locations across India, Bangalore being our headquarters. Among many partnerships, we have strategic partnership with Esri India catering to GIS requirement of our customers. In addition, we have partnerships with Dassault Systems for analyzing virtual twin in manufacturing and mining sector, with EOS for additive manufacturing requirements, Human Solution for ergonomic solutions for automotive and aerospace industries, with Prestiges and MAC Technologies for military simulation training needs of aerospace and defense industry. With respect to EDA, we are closely working with Synopsys. We also have signed up with Festo for Industry 4.0 solution for academia. We have a dedicated sales, support, marketing, and customer satisfaction team for addressing customer-specific business requirements. Coming to the mining sector, we have helped organization to incorporate technology in order to have more sustainable approach in mining. Majority of the mining related organization in India are supported by us for mine planning and other technology. We are happy to have one of our esteemed customer, Hindalco, to talk about how they use Esri or like ArcGIS for their specific requirements. In today's webinar, we are joined by our guest speaker from Hindalco Industries, Dr. Rahul Mitra. Dr. Rahul is currently working as a section head, technical service and mine planning in Chakla coal mine. He has 8 years of work experience in the field of coal and iron ore mining. He has done his graduation, post-graduation and PhD from Jadavpur University, Kolkata. Our second speaker is Yogesh Karyakarte, who is working as a senior manager GIS at EDS Technologies. Yogesh has more than 13 years of experience working in various reputed organizations such as central universities, research organization, NGO, and private sector. He has worked on various remote sensing GIS application. He is a recipient of Nehru Grimson Fellowship Award from the President of Iceland. He is currently leading a GIS technical team at EDS Technology to provide customized solution for specific customer requirement. Before we begin our discussion with Dr. Rahul, I want to inform you that we shall take up questions in our Q&A section after the presentation. I request if you have any questions, you can drop them in the chat box. Let's get into a discussion with Dr. Rahul. Dr. Rahul, want to understand, like whenever any organization gets an approval for mining lease areas, the first and foremost thing is to demarcation of mine lease area and get the land records, approvals, permits, and government regulation. As per the government regulation, basically a data management. I'd like to understand from you how Hindalco is managing the mine lease areas with respect to data management, Can you explain about your LMS application, which was built on ArcGIS?
Thank you very much for getting such kind of beautiful opportunities. So I am saying with a just one of our greenfield project. That one is Chakla coal mine. Chakla coal mine, we have Hindalco has awarded in the year of 2021 through e-auction, and it is well established that data capturing and data representation is very much important, and from the starts of the mining. So when we get the wasting water or CMDPA, so after that, we have to do all the digitization work related to the land details. So for that one, before going that one, I just want to give you an overview of our Chakla coal mines.
Okay.
That our Chakla coal mines is located in Jharkhand,
Rahul,
in Latehar. Yep.
Can you put your slides on slideshow mode?
So
Thank you.
we have our coal block is located in Latehar district of Jharkhand. It has a mining lease area of 786 with an extractable reserve of 71 million ton, and the grade of the coal is G11. And we are planning to do the mining as an open cast, and for coal removal we will use surface miner, and for OB removal we will use simple shovel dumper methodology with the drilling blasting option. Now we have implemented our land management systems through ArcGIS from the very beginning to understand the land distribution within our block area. Actually, in our coal block, there are different types of land. There is notified forest land, there is Dangal Jhari land, there is GM land, there is Raiti land. And each of type land have separate types of approval processes. Just like forest clearance, just for notified forest, we have to get the forest clearance stage 1 and stage 2. In case of Jangal Jhari, we have also has to get the forest clearance, and with that also we have to take the clearance from the cabinet. And for Raiti land, we need to file the CNT permission, then it has to be approved, and then we will do the registry. So these are separate land types and different types of land acquisition processes. So for that, it's very important for us to identify the land, which type is that one, and their distribution in the block area. So for that, we first done the color code with respect to the different types of land, and then we have incorporated the details of each type of land. Suppose a plot is there. Now the plot number, plot type, area. If that one is a forest land, then what are the number of trees? If that one is a Raiti land, then what is the name of the owner? Such kind of details has been incorporated. Now, for in case of notified forest or jungle jhari or government land, the process of acquisition is go through with all the chunks. Means I have been notified forest of 100 hectare, then the file will move at a at a at a 100 hectares. So there is no scope to break up on that one. But in case of Raiti land, their document verification, CNTA filing, permission, and registry all are based on plot wise. So for that one, in case of Raiti land, the status has been also demarcated with different color code to better visualization what is the status on that. So this one is an output of our color coding on land types. Here you can see that we have demarcated notified forest with a deep green color, and for JJ land we have marked it with light green color. So after doing this such kind of color coding with different types of land types, we get a clear-cut idea about the land distribution. And we also from this we get a clear-cut idea that the southern coast part of our block is highly forest area, and the middle to north part is dominated by the Raiti lands. Now, I have already told you all that within Raiti land there are different types of status. And here I have marked the Raiti land with two different colors. That one color is demarcating that those documents of the riot we have already received and have completed our verification. And rest of the brown color is that the riots, those documents we have not received. So after doing this, we can get a clear-cut idea that which riot we should target in our priority basis to get a full chunk of righty lands, because land acquisition is mainly depends on how I am doing the mining. So I will later also will disclose that one, that what is the purpose of doing this kind of color coding. And this one is a this one, from this one you can also see that here we have done we have incorporated all the details of plot wise, just like its plot number, khata number, what is the land type, what is the plot type, what is the area, name of the riot, and what is the status. Also, that in like this we have marked it that CNT application has been submitted for the whole area. So this kind of LMS work we are doing with ArcGIS for getting a clear-cut idea about what is going on land in our block. So that is, I hope this one you will get an idea about what.
Yeah. Thank you, Dr. Rahul. And this gives a lot of information about each of the plots. All the details have been accommodated within this particular block, I think, like all the attributes related to the plots. Uh, I have one more question. How are you using the ArcGIS application for your mine planning and even for a long-term, short-term, and even for reclamation of your mining areas? If you can give some information regarding that, that will help.
Yeah, sure. Why not? So for that, what we have done in our next stage, we have superimposed our stage-wise mining plan. So you can see here that the color coding is the base map, and with that we have superimposed our first year mining plan. So in the topmost portion you can see the pit area, and on the left hand side there is the dump area, and from middle left portion is the infrastructure area. So through that one we can properly get an idea that which plot I need or I required at the beginning, which plots are going to be my dump area, and is a righty land or notified forest land, or what kind of type is that. And you can see that our peat and dump area are mostly is within the righty land area, and as it is mostly in righty land area, so within that you can also see that the first year pit area, most of the documents we have already received, and those we have not received we are working on that with a target that we can get the document for verification and file the CNT at least for next 30 days. So this will definitely gives an clear cut idea that which land we should target it on a priority basis. And this one you can see that this one is the map which is superimposed. The situation is after the 5th year. Now if I compare my land acquisition status as on date, then I can see that overall 75% of riots document, those are falling within 5th year pit and dump. I have for pit area up to 5th years I have sorry, for dump area up to 5th year I have get near about of 75% documents, but in case of pit, if I look after on 5th year I have received near about 30 to 35%. So on target on that one I have to work on that. So right now I need to be more focused on the pit area plots, and this one is the stage-wise mine planning that we are doing with the help of superimposing of mine plan and land management system. And for reclamation you can see that we have started we will start our plantation and in-pit dumping from the year. Actually, we'll start our plantation from the end of first year, and in case of our in-pit dumping, we'll start after the second year. So that one is well established through this diagram also. You can see on the northern part, which we have mined in first year, already done the in-pit dumping and already done some plantation. So in which area we will do the reclamation, that one is also can be monitored through that one. So from my side, that one is this. So I think it will be okay to get an idea.
Thank you, Dr. Rahul. It gives us an overall idea of like how when you get a mining lease area, how does the land acquisition or land records are taken, and then how the whole planning for short term and long term has been done. I know you have a lot of digitization planning, but here are a few topics that we can discuss. I think the rest probably some other time we can discuss. And moving forward, thank you, Dr. Rahul. And
thank you very much.
yeah, and if audience have any question, you can put them in the chat box, and at the end of Mr. Yogesh presentation, we'll take up those questions, and then we'll answer you that. Can we, when I hand over the stage to Yogesh for his presentation.
Thank you, Vinay. Yeah, thanks a lot, Vinay and Rahul, for your discussion. Now I will discuss more about like how this GIS application can be used for sustainability. We already know that there are various applications which will be carried out through using GIS. Many activities can be carried out using GIS applications. For example, we can have the road connectivity in a mining area. Before planning also we can do this. We can also do land use land cover analysis. We have topographic maps available through GIS. We can do geological survey. We can do the geochemical assessment also using GIS application. We can do asset management. Whatever the assets are available within that particular mine, those all assets we can digitize. We can also do asset tracking. So if it is a moving asset, for example, crusher, if you are moving it to some other place, so that also you can track. You can do fleet management also. So there are many haul trucks which are moving around in a mine. So that also we can track in live also. We can do impact assessment of particular mine, how those activities are impacting to the community and in the ecosystem. We can also create the mine activity area plans. We can create reclamation plans, then resettlements maps we can create. We can actually use the GIS application for supply chain management and logistic. We can also create various websites also using GIS, which will be very useful to show your locations of different mining areas. Also, we can create the dashboards, which will be very useful to actually communicate regarding your day-to-day activities to the stakeholders, to the management as well. We can use also the GIS application for blast hole mapping, drill planning, for inventory map management, and GIS is very much useful for selecting a suitable site for mine waste dumps. But in today's webinar, I will be more focusing on these particular points. We will be discussing about mining activities and its effects. Various acts and policies are there in India regarding mining activities. Then I will discuss about the SDGs also, the Sustainable Development Goals. Then the impacts, environmental impact, as well as the impacts on the local community when we are doing various mining activities. And various applications are there which are useful to actually estimate the impacts. So those impacts may be on the surface water, groundwater, forestry, agriculture. Then there will be noise pollution, air pollution, and the mining activity will also affect the biomass and carbon sequestration. So all those points I will be discussing in this webinar. So basically, we know that there are various activities which are carried out during the mining, and obviously we know that there is a lot of valuable minerals we are exploring. But we have to understand that there are a lot of effects on the surrounding environment also and the local community. So there is a lot of effect on natural environment as well as human health when we are carrying out these kind of large scale activities. At different stages, different types of effects are there. For example, in case of mine exploration, construction and operation, it will have effect on the deforestation. There may be soil erosion, there may be a contamination of soil, or even the local streams and wetland may get contaminated due to the activities. Also, there will be noise pollution, then air pollution due to dust and emission. During the mine abandonment and decommission, or even for reclamation, during that time also there will be some kind of effect. It may cause effect on the soil and water contamination. And lot of infrastructure is constructed for mining activities. For example, there may be construction of roads, ports, railway tracks, power lines are being constructed, and it affects the migrating routes. Many animals are migrating from one place to another, and those may actually cause impact on the migratory routes. So animal may not be able to travel as per their traditional routes. So these are the different activities which are carried out in different phases of mining, and these are the different mine hazards. For example, in case of operation, when extraction or waste rock management, so during that time there will be a lot of noise pollution, vibration, and there will be problems regarding waste rock or tailing also. So we need to actually consider all those activities and different kind of hazards which are caused due to this various mining activities at different stages also. So coming back to the sustainable mining, what is exactly the sustainable mining? So sustainable mining is when we are extracting the minerals, we also need to improve the social and economic environmental outcomes. So we have to consider the social, economic and environmental impacts also while we are doing mining activities. And actually we have to understand the future also, like future there will be different kinds of needs, and future generation is also will be depending on those sources. So we have to understand that also, and what will be the effect of the activities in future generations. So that also we should understand. And basically sustainable mining means we have to be financially profitable, but along with that we have to be technically appropriate, environmentally sound and socially responsible. And basically we have to consider the triple bottom line: economic development, environmental impact, and also the social concern. So for to truly shift this system to the sustainable mining, we have to depend on various acts and rules, and government and companies must recognize the social impacts of mining and enact laws and regulations that require community consultation. So without consultation with the local community, we should not progress ahead. So these are the different policies in India. Indian government are like carrying out a lot of activities. A lot of acts has been created, a lot of policies has been created regarding this. For example, National Mineral Policy has been created in 2019, which actually focuses on environmental, economic and social justice. Also, Ministry of Coal has established a Sustainable Development Cell in 2019, which actually is aimed for environmentally sustainable coal mining in India. Also, we have to consider that national frameworks and policies are there created by the government, but implementation is a big task, and all the mining communities and industries or mining companies, they have to consider these various frameworks and policies. As I was mentioning, there are various acts has been created. Way back in 1957, the first act has been created, actually in 1957, and then it was updated in 1957. So there are a lot of various acts has been created. Till date, there are, like, for example, the sustainability and mining guidelines has been created in 2020. So regularly these acts has been created and policies has been created to regulate the mine activities. Talking about the SDGs, we already know that the Sustainable Development Goals has been created by United Nations, and in 2018, United Nations points out that there are 10 SDG goals which are directly concerned regarding the mining. For example, poverty is there, gender equality, clean water, affordable and clean energy, decent work and economic growth, industrial and innovation and infrastructure, responsible consumption and production, climate action, life and on earth, and peace, justice, and strong institution. So all these 4 SDGs are there, which are directly concerned regarding the mining activities. Coming back to the actually estimating impacts. So we know that there are various activities which are carried out in the mining, and we have to actually estimate the impact assessment. Before starting the activities itself, we should do the impact assessment, and you know that there are regulations which are like compulsory or mandatory to submit these kind of impact assessment report to the concerned authorities. So in different stages, as I was mentioning, there are various processes which are carried out during the impact assessment. So for example, screening, you can actually use the proximity analysis in GIS. Then for scoping, like what is the effect of this particular activity, how much area will be get affected due to these activities. So for that, we can create buffers around the mine plans, and we can estimate the area which are getting affected by these mining activities. And we have to create baseline database as well as the estimate the impact prediction. So before starting the activity, what is the current situation in the field, what kind of vegetation is there, what are the local communities, how many people are staying over there, what kind of natural ecosystem is there, whether there are any natural ecosystem sources are there. For example, is there any river or any freshwater lake is there. So those kind of all natural resources should be mapped before starting the activity, and we actually have to see whether the activities will have any effect on those natural ecosystem as well as the local community. So in each of the stage, we will be using the GIS applications, and even for evaluation. So basically, we have to actually rank those effects. So in each of the activity, there will be impact on the local community, which we'll be discussing in later slides. So in each of the stage, we have to consider those impacts. So basically, to start with, if you are very new to the GIS, this kind of analysis you can easily do. For example, this particular area is captured using satellite images, high resolution satellite images, which are freely available through ArcGIS software. So you can see in 2014 the situation in the field, how much area was covered by the vegetation in this particular area. But if you come to 2021, a lot of construction has been going on, a lot of activities, mining activities has been carried out in this particular area. So you can see a lot of vegetation has been lost. So these kind of analysis you can easily do, and you can actually go ahead and actually estimate the area also in different types of vegetation, like if it is dense vegetation, sparse vegetation, and how much area got affected due to this mining activity. So that areas you can actually map through the GIS application. Then you can actually estimate the tailings. So for example, if you are dumping tailings in a particular area, GIS software can help you to actually estimate the area. In the field, it's very difficult to actually find out the area and estimate the total area, but it's very easy using remote sensing and GIS software. So basically using various band techniques, band ratio technique. In this case, they have used natural differential tailing index. So using this normalized differential tailing index, you can actually estimate the area. So you can find out the area. For example, in this case, you can see this red area, which is showing the tailing which has been dumped in this particular area. So this kind of analysis you can easily do using remote sensing and GIS. You can also estimate the land use land cover changes. So for example, in this case, the land cover was there, mostly it was covered by forest and agriculture. But when we started this particular activity has been, this mine is in Chhattisgarh, and when they started these activities, there were a lot of impacts in various areas, especially for forest and agriculture. And you can actually see how much area got impacted. So you can see even in the percentage also you can calculate the area which has been impacted, which may be impacted highly, medium impact is there, or low impact is there, or there is total deforestation in the area because of the mining activity, as well as the impact on the agricultural land also you can find out, whether there is a impact, high impact or low impact. So those kind of analysis we can use easily do. So for that, basically we use the satellite images. A lot of satellite images are freely available in ArcGIS. So using Landsat images or high resolution images as well, you can find out the changes in before starting the mining activities and the current situation. And this can create actually your base map through which you can consider when you are actually planning for the reclamation. All these ecosystem has to be restored. So accordingly, you have to plan your restoration processes also. You can actually use GIS for mapping the surface water quality. For example, this particular study has been carried out in Jharkhand. So you can see in these two maps before post monsoon the concentration of ferrous. So basically this study has been carried out for heavy metal. There are a lot of metals available in the area, and you can actually estimate their concentration in the field. And the estimates you can actually plot in the GIS maps and see their extrapolate that to find out the concentration in different areas. So for example, this is the post monsoon concentration, and you can see that there are these areas which are dark blue in color having very less, around 200 to 400 concentration megagram per liter concentration of iron. But if you see the pre-monsoon season, it has been increased, so it goes up to 300 to 600 also. And in the central area also, you can see there are a lot of areas which has been like it was around 800, which has increased up to 1500 plus. So these kind of analysis you can easily do using GIS. You can actually use it for groundwater quality also. This particular study has been carried out in Andhra Pradesh. So you can see at different locations they got the measurements in the field. They have the sampling locations which are denoted in the yellow points, and from that you can actually estimate the impacts. So you can actually see the water quality status, and various areas, especially these red areas, has been hampered due to these activities. So this kind of analysis is easily done using GIS. You can actually use the air pollution modeling also. For example, this particular study is carried out using Landsat 5 TM sensors, and you can actually estimate the AOT from this aerosol optical thickness, and from that you can actually see how much is the concentration of PM, particulate matter 10, in this particular area. So you can see the higher concentrations are there in this whitish area, and lower concentration. Basically, the this particular area has the mining activity going on. You can see this location, and from there you can understand that on the eastern side there is a lot of air pollution because of these activities. You can also actually model the assessment, model the oil spills also. This particular study is carried out in the Chennai region, and they have created a model through ArcGIS. And you can see that at different seasons, if there is a spill in a particular area, how the particular oil will move on the surface of ocean. So that kind of modeling is also possible, and at different level, like after 3 hours, after 5 hours, after 10 hours, how this oil spill will move in a particular direction. So that kind of modeling is also possible using GIS. You can actually estimate the volume also. So this particular area was having the stockpile dump. So this is that waste rock has been dumped in this particular area, and using the LIDAR data, point cloud LIDAR data, you can actually estimate the volume also. So basically, this area has been dumped. This waste material has been dumped in this area. So for this kind of analysis, you can actually use the high resolution satellite images, or even the drone images you can use, by which you can actually calculate the volumes in the ArcGIS software. You can also use GIS for estimating the noise impact. So this particular study has been carried out where you can see the different areas. There is a waste dump area, there is tailing dump area, and basically they were using CAT's 777D dump trucks, and there are a lot of activities going on in this particular area. and by using the modeling, you can actually predict what will be the effect of noise pollution. So in using this, they have actually estimated the decibel values also, what will be the value at different location because of those trucks and motor graders. And from that you can actually estimate the effect in particular area. For example, you can see here there are a lot of building construction or local community is over here. So how much will be the impact of this noise pollution in this area? And if you create a noise band, that effect will be minimized. So that kind of analysis is possible using GIS. You can actually use the GIS for monitoring the carbon dioxide emission also. For example, this particular study, they have actually delineated the network of roads within this particular mining area. And you see that you can actually estimate the distance which is traveled by different types of trucks, which is empty or loaded trucks. And we also have the emission factors, by using which we can actually estimate how much the carbon dioxide is emitted per unit kilometer, or per kilometer if a dump truck is traveling empty or loaded, how much will be the emission from that particular truck. And by estimating the total length traveled by that truck, you can actually estimate the total emission caused by that particular truck. So that kind of analysis we can do using GIS. We can also use the GIS for estimating the impact on the biodiversity, biomass estimation. So we can use NDVI for that purpose. So basically, we can see in this particular area, there is a lot of biomass. The living plants are there in this particular area. And this is the particular boundary of mining lease boundaries there. So how much is the effect of this particular activity in and around the mining activity, that you can actually find out. So you can see in this particular area, which is outside the mining zone, it has very high biomass density. But if you go towards the area of mining activities, it has been decreased. So using NDVI, we can actually estimate the biomass of this particular area. And from that, actually, you can also estimate the carbon loss also. For example, this particular study, you can see that these are the underground coal mines in this particular area, and it has affecting the vegetation which is present on the surface. So even though there is not direct impact on the surface vegetation, the major impact has been carried out on the vegetation, because of which the photosynthesis has been decreased in this particular area. Because of that, the trees in and around this particular activities can't absorb the carbon dioxide. So the sink has been decreased. So you can see that these red areas has very less carbon concentration. So sequestration has been decreased in this particular area compared to the area which is outside the activity zone. And you can actually use this for estimating the carbon sink in a particular area. So for example, this particular area, they have started the reclamation, and before starting also they have done a lot of planning and find out that if they maintain a different type of activities, and if they could if they stop the reclamation activity at that stage itself, they could have sequester almost 59,90,000 tons of carbon, which is almost 898 millions of US dollars. If they carry out and continue the reclamation, and if the 20% of the area got forested and 80% of the grassland has been covered in this particular dump area, in that case they would have sequestered additional almost 6,03,000 tons of carbon, and it would amount 90 millions of US dollars. And if they cover entirely all the 100% of the dump area has been totally covered, in that case they could increase the sequestration carbon by almost 7,52,000, which amounts almost 112 million of dollars. So basically for this, what they have done is they have actually estimated the land use land cover before the activity. So this is currently showing for 2010, but they had done it for the 1987 before the start of the activity. Then they carried out the land use land cover analysis for 2000, 2010, and from that they have estimated that how much area is actually getting converted into different types of land use land cover, and each land cover depending on the vegetation, it has some carbon sequestration process, and by which actually you can estimate how much carbon is synced in this particular land use in terms of tons. And using those these values has been calculated using the 150 tons per dollar values at that time, but currently the rates are almost $30 per ton. So you can understand, like, if you could reclaim all the area in this particular reclamation activity, then there will be a lot of carbon will be sequestered in this process. So I think this is from my side.
Thank you, Yogesh, for a wonderful presentation. It was insightful, a lot of information. And thank you, Dr. Rahul, giving us a clear idea of how Hindalco has been using GIS technology from Esri for their land record LMS, or like land management system. And I would thank all the audience for patiently hearing us. And you will be getting a feedback form. I would request each and everyone to fill that and then give us your feedback so that we can improve on our future webinars. Until then, thank you all.